All right, so our final topic for Unit 4 is solving systems of inequalities as opposed to equations. And mainly you're going to do this by graphing. So you're already familiar with graphing one linear inequality. We're just going to put two of them on the same coordinate plane. So you know that when you graph, you always want to make it in y equals mx plus b form. Most of the time you'll be able to do that with your problems, except in the case where you have, like on the next page, you have an x equals and no y's, you won't obviously be able to solve for y. Once you have it in slope-intercept form, then you're going to graph each inequality. So remember to decide, is the line going to be dotted or solid, and are you going to shade above or below? Once you have one shaded region and another shaded region, so let's just say we have our graph here, and we have one equation here that goes this way, and another equation here that goes this way. So notice that you have your two shaded areas that touch each other right here. We're going to make this section really dark because we want to know what is the actual solution to the system of inequalities. Points in this region satisfy the green inequality. Points in this region satisfy the black inequality. Well, here is the point, or all the points that satisfy both inequalities. So this region contains all the points that are solutions to the system of inequalities, and there's an infinite number of solutions within that. So the first problem actually doesn't have to do with a graph. You could do this algebraically. Tell whether each ordered pair is a solution to the system. So solutions are points that make the original problems true. So if you take your x and y and substitute into the top inequality and the bottom inequality, and if they both turn out to be true, then yes, it's a solution. If one or both are false, then it's not a solution. All right, so if you have y is greater than or equal to 2x minus 9. So we have 2 is greater than or equal to 2 times 5 minus 9. So 2 is greater than or equal to 10 minus 9. And 10 minus 9 is 1. So is 2 greater than or equal to 1? Yeah, 2 is greater than or equal to 1, so that's good. And then you're going to do the same thing with the second inequality. Y, which is 2, 2 is less than 5 minus 5. So 2 is less than 0. Is that true? Probably not. So that's a no. Since one of them is a no, then overall this is not a solution to the system. Okay, so final answer is no. All right, but on the next page, these are the ones we're actually going to graph. All right, so I'll try to leave up part of the rules. All right, so first thing is you need to write in y equals mx plus b form. So for my first inequality, it says 2x plus y is less than negative 3. Well, I need to get y by itself. To undo my 2x, I subtract 2x, and I have y is less than negative 2x minus 3. And I have y all by itself. So there's the first inequality. All right, I'm going to graph. Okay, so I need to decide, is it dotted or solid? Well, I have less than. So this tells me I'm going to have a dotted line. And it's less than, so I know I'm going to shade below. All right, recall that you're just going to start with your y-intercept. My y-intercept is negative 3. I'm going to start at negative 3 on my y-axis. I'm going to go down 2 and over 1. And like before, I'm going to try to make as many points on this graph as possible, since I don't know where the other line will be drawn. All right, it's dotted, so make sure that you create a dotted line. And then I need to decide where is above or below for this graph. Below is anything here. So I will use a green highlighter. All right, so anything in this section, you know, this keeps going forever. All right, second inequality is 3y minus 4x. So I'm going to add 4x to move it to the other side. I have 3y is less than or equal to 4x minus 18. And then I need to divide by 3. And this gives me y is less than or equal to 4/3 x minus 6. Y is all by itself, and therefore I'm done solving for y. All right, going back to my rules, well, I've got another less than, but this time it's less than or equal to. So I know I'm going to have a solid line and shade below. So solid line, shade below. All right, and just like anytime you graph, you're going to start with the y-intercept, so -6. I'm going to go up 1, 2, 3, 4, 1, 2, 3 to the right. 1, 2, 3, 4, 1, 2, 3 to the right. And then I'll go in the other direction. 1, 2, 3, 4, and 3 to the left. All right, this time I want a solid line. And just like the last problem, it's another shade below. So find my boundary line. Shade anything below here. Try not to go over your line. All right, and then now you're looking for your overlapping region. Well, here's only green, here's only blue, but here's both. All right, so I'm going to make this darker, and this is my solution set. So any point in this little triangle section would satisfy the inequality. This line would be included because it's solid. This line would not be included because it's dotted, and so points on that line are not part of the solution set. All right, last problem. We've got x is less than or equal to 4. Well, there's no y, so this is it. Now, this is a special case. This is a vertical line. So when I draw it, I go to 4 on the x-axis. Right? Don't forget which one is x and y. I need a vertical line. I need to decide is it dotted or solid. Well, it's less than or equal to, so that's a solid line, and I would shade below. All right, so I'm going to draw in my solid lines vertical. Now, the only issue here is that there really is no above and below when you've got a vertical line. You have a left or a right. Well, less than 4 would be 3, 2, 1, 0. So I'm really shading to the left. Okay, so anything to the left of that line. And then on the next inequality, I need to solve for y. So I'm going to subtract 3x. I have negative y, don't forget that negative sign, is greater than negative 3x plus 2. Now, I don't have y by itself yet. I need to divide by -1. So I have y is less than. Notice that I divided by negative, so I needed to switch my symbol from greater than to less than. This becomes positive 3x, and this becomes -2. Now I have y by itself. It's less than, so I'm going to shade below. And since there's no line underneath, that means that my boundary line is dotted. And the points on that line are not included in the final solution. All right, so I'm going to start at -2. I'm going to go up 1, 2, 3, over 1, 1, 2, 3, over 1, 1, 2, 3, over 1, 1, 2, 3, over 1. I'm going to go one more. All right, and I'm going to go down 3 over 1 just a couple times. All right, so I know I'm going to have a line here, and I need to shade below. So anything below the line will be included in my solution set. And you're looking for where do your two colors overlap. All right, so you can see in between the two lines in this little sliver. Since both of the lines are solid, that means that the solid lines include points that are part of your solution set. Oh, I'm sorry. I didn't listen to myself. So this is a dotted line. All right, let's see if we can fix that. My mistake. Good thing I caught it. So this should be dotted. Okay. Now, in the solution set, this is a solid line. This is a dotted line. So this line does not count as part of the solution set, but this does. Any points inside all do count.